Hi, everyone. Welcome on board. Let's just give it a couple of more minutes before we begin. Okay, well, I see that it's already 3 o'clock. So in favor of those who came here on time, I think we should begin. So hi, everyone. My name is Gediminas. I'm from CloudVisor, and I'll be hosting today's webinar on CloudFormation from zero to hero. We have a very special guest today for you guys, Laimonas Sutkus, CTO at Biomapas, who will be delivering the main presentation today. Laimonas, would you like to say hi to our audience?
Yes, hello everyone. I would say not that special, as it's probably the 5th presentation already. So again, hi everyone. Thank you for joining.
Well, I'm very happy to have you on board and for joining today's event. I'm sure it will be very interesting and useful for our audience. So before we begin, let me just say a few words about CloudVisor and what do we do here in case you haven't heard about us before. Just get my slides. Yep. So CloudVisor is an advanced tier AWS partner operating in the Baltics and Nordics region. We work closely with Amazon Web Services to support current and new Amazon Web Services users in our region. Our main business line is Amazon Web Services resale that is being used by a number of companies in the Baltics. So if your company is currently using Amazon Web Services, I strongly suggest check out the benefit packages that we offer as a bonus of our AWS spend. Next to that, we try to do a lot of things to build the local Amazon Web Services community, and this workshop is a good illustration of such. Next to it, we try to do a lot of things to build the community, and Laimonas will be our main speaker today. My role will be to support him along the way. So before passing the stage to him, I would like to remind you a few things. First of all, this webinar is being recorded, so you will receive a recording tomorrow, and you will be able to watch it whenever you feel like you can. Secondly, your questions are very, very welcome. So please submit them either in a Q&A section or in the chat box. We will go through them either at the end of a presentation or if we have time in the middle of it. And if you still don't have a training account, but you would like to get access to one, reach out to events@cloudvisor.eu and we will give you the access right away. I believe that's all from my side. Laimonas, are you ready to take over?
Yes, sure, of course.
Awesome. So I'm stopping to share my screen and go ahead when you're ready.
Okay, so then I'm starting to share mine. Yep. So can you see my screen?
I believe so. I can see it clearly.
Okay, so let's hope everyone does also. Okay, so let's start. So thank you everyone for coming. Today we are going to talk about well, I at least would say a very interesting topic, a very important topic, especially in today's modern architectures, where we have microservices that dominate. So it is infrastructure as code related presentation. And we're mostly going to talk about the AWS's implementation of such principle, which is called CloudFormation. And we will start from very, very simple terms. What CloudFormation is, how do you interact with it, how do you write CloudFormation templates, and then we will shift to something more advanced. We will touch a little bit on AWS CDK, which for me personally, it is probably one of the best tools AWS currently can offer from the infrastructure management perspective, of course. So let's start a little bit of introduction. I am Laimonas Sutkus. I'm currently working in Biomapas as a Chief Technology Officer. I've been playing with AWS for over 5 years. The best part of AWS, I think, is the serverless part. All the lambda functions, S3 buckets, DynamoDBs, Kinesis streams, all of these things I absolutely love. And as I mentioned already, this would be my 5th presentation that is being hosted by CloudVisor. And as a last slide of introduction, I would like to mention that we are hiring developers. So if you are a Python or AWS developer or Angular developer, please don't hesitate to write me. My email is laimonas.sutkus@biomapas.com. Here in our team, we are working with really cutting edge technologies, such as this CloudFormation infrastructure as code principle. So let's have a chat. And for today's presentation, I would like to talk from the perspective on how we manage our infrastructure, because there are quite a few ways how we can manage it. And the most basic, the most fundamental way of managing the infrastructure is a manual way. And it is the easiest way to start. So for example, AWS has a wonderful AWS management console where you can do pretty much anything. You can create all those EC2 instances, clusters, Dynamo databases, Kinesis streams, and IoT devices, you name it. So you can do everything basically from this AWS management console. However, even though it is easy to start with such consoles and manual configurations, this approach tends to have quite a lot of downsides. And the first one, and probably the most obvious one, is that if you have, let's say, a few environments, as you should, for example, dev, stage, and prod, it is very, very hard to have mirror-like infrastructures. So, for example, if you create a new Lambda function or a new endpoint in a dev environment, then you need to create exactly the same resource or exactly the same thing in staging environment, and lastly in production environment. And as we're human, these things can go wrong, and this approach is very error prone. We might forget to enable something, to disable something. We might do some accidental misconfiguration. And at the end of the day, we might have one state in our staging environment and another state in our production environment. And this is never a good thing. Yeah, this is never a good thing. And also, obviously, it is very time consuming, especially when you have, imagine you have thousands of microservices, and you have very complex structures. Let's say you have an ECS cluster, okay? You have an ECS cluster, which should have an load balancing, auto scaling group, and other thing. And imagine you want to create a new cluster to handle other business logic. Well, it is quite time consuming because now you need to do all these, create all these load balancers, auto scaling groups, target groups, roles, security groups, the ECS cluster itself with all those tasks and another thing. And it is especially time consuming when you have 3 different environments that you need to deploy to. So in summary, manual way is a good way to start. However, it is not the best way to start. So how we can automate it? Because if manual is not a good way, then let's do the automated way. And probably again, the easiest part to automate it is to write some scripts. And I have one example here. We imagine we have something like deploy-infra.shell file, which is a simple bash file which contains quite different API or in this case CLI commands to create some resources in AWS environment. So in this case, we create here we create a bucket, we create a role, and we create a function and attach that created role. And this is quite a fair, I would say, a fair approach because now there is so-called reproducibility, where you can deploy to dev, stage, and prod from a single place. So imagine you add a new CLI command to create a new lambda function. So it would be, let's say, a 4th line. And you know that once you deploy this shell file to all 3 different environments, all of those resources will be configured exactly the same way. And this is very good. However, this approach itself is far from ideal. Imagine you have a very big shell file, thousands or 10,000 or even 100,000 lines of such code. There is no retry logic, and if something fails in between, in the 10,000th line of code, you need to do basically everything all over again. Again, if something fails in the middle of your this scripted deployment, there are no rollbacks, so you can't roll back to a previous state of your infrastructure. And I would say the biggest drawback of such scripts is that they create resources. There is no way how you can update them. So as you can see, we are calling the create bucket, the create role, the create function. What happens if we want to change the, let's say, the runtime and the code itself? What happens if we need to change the role or maybe roles policies? You cannot create a role on top of the role because the initial role exists already. So this is not a good approach to maintain your infrastructure. And that is why we have things like CloudFormation or Terraform. And both Terraform and CloudFormation approaches are so-called declarative approaches. And what it means is that it lets you think about your current state of your application and about the next or the desired state of your application. And you don't need to think, how are you going to get there? So this would be a good illustration of such a declarative approach. This is a piece of code taken from a CloudFormation template, which was written in YAML. And we see that we have created here two resources. One is the web server security group, and another one is web server elastic IP address. Now imagine we deploy these two resources. They appear in the AWS environment. And let's say we decided that HTTP protocol with the open port of 80 is no longer suitable for us. We want to enable only the HTTPS. So what we can do is we can simply change this from 80 to, I believe, 443. So here 443 and here 443. And we would simply send that updated CloudFormation template to the CloudFormation engine. And now we don't care how many changes we've done or what changes have been done. We just care about that next state. And the next state is the, let's say, HTTPS only state. So what CloudFormation does from there, it looks what was the previous state, what is the desired state, and it calculates the change set. And the change set is basically a list of changes or change actions to be done to reach that desired state. And CloudFormation now tries to figure out how it can approach that state, and it executes a bunch of commands. And if everything succeeds, now you are left with the desired state, with that HTTPS only state. And you never ever cared about how you got there, because CloudFormation took everything for you. Now, this declarative approach definitely has lots of advantages. It is really easy to automate. You can only think about the desired state. It is very, very well reproducible, because now you can deploy to multiple environments very easily. However, at the same time, it has some disadvantages. And at least for me, the biggest disadvantage is the syntax, is the code, or air quotes code itself. I don't think it is human readable, and I don't think humans should read these templates. I think it should be left for computers to read, but not humans. And this is why we have next level approaches. And here we see, after the declarative, we have DOMs, or document object models. And even the next step after, we have components. But before we jump to these, I want to start the first session of our workshop. I want everyone to understand what CloudFormation is, because all of these other approaches, next steps like DOMs and components, are usually built on the declarative approach. So this declarative thing is the fundamental level that is great for us to understand how things are working on a deeper level. So without waiting, let's start our first workshop session. And I have prepared some training material. It is in my personal GitHub repository. It is called AWS CloudFormation 1-on-1. I will try to share this URL with you guys. Okay, I only messaged to panelists. Can I message to everyone? Yes, I think I can. Can you guys confirm in the chat that you received that URL?
I think we should be fine. It says panelists and attendees. Yeah, we got it.
Mm-hmm. Okay, you got it. Awesome. So I hope that everyone has a Git tool installed and everyone is using Git. So let's simply copy that URL and let's simply download it or clone it, because this is going to be our main training material. I have a preference of IDE. I usually use PyCharm for Python-based code, but you guys can use anything you like I know, what's that Microsoft tool? Visual Code, yeah, or Sublime Text, whatever. You can use whatever you want. For this demo purposes, I will use PyCharm. Okay, and I will open this CloudFormation 1-on-1, the thing that we downloaded. Okay, and as you can see, we have two folders. The one is session 1 for the CloudFormation, and another folder is for the second session with AWS CDK. Okay, so currently we are interested with the first one, as it is our first session, the fundamentals session, and we have in total 6 steps. So we have in total 6 CloudFormation templates, which we will try to deploy and see what happens. So before we start looking into those YAML templates, I will ask everyone who is participating in the workshop part, not just the presentation part, but are actually willing to execute some steps with me and have received credentials to follow things in AWS environment. So I will ask everyone to log in now to their provided AWS environment, and we will start. I will give you a few minutes for some of you who haven't logged in, and we will start very, very shortly. Okay. Okay, so let's continue. Let's say the preferred service, or the only service that we're currently interested in, is the CloudFormation. So there is the search bar. You can simply write CloudFormation and simply click on this service. I'm not sure how about you guys. Most likely it is empty for you. I have played a little bit with this service prior to this presentation, just to ensure that everything works fine. But if you don't see the screen, you can simply press on the left part and just press on stacks. And you will be presented with some empty list, I guess. Okay. Going back to our CloudFormation templates, let's open the first one. And let's see what we've got there. Well, it is probably the easiest example I could think of. Here we are creating an S3 bucket, and that's it. We say that we have an always there part, which is called resources, and all of the resources, Lambda functions, DynamoDBs, S3 buckets, have to go under this under this entry, and then we create all other resources. So the first one, the first entry is always the name of the resource, and or should I say the ID of the resource. So in this case, I have chosen to name it S3 bucket. And lastly, you tell all the properties, types, and other things that is associated with your new resource. So for the CloudFormation, I tell that, okay, this S3 bucket name is of type S3 bucket. And let's try to simply deploy this 3 lines CloudFormation template, and then let's see what happens. So going back to our CloudFormation service, we click on create stack. We want to create new resources. We have an already developed template and we want to upload it. So we click on the upload a template file. We choose a file and we choose our first resource. We hit next. Now we need to think of the stack name, and then stacks are basically a wrapper around a CloudFormation template. So let's say in order to today's hosts, CloudWiser stack 101. I think it will suit us. Now here you can pretty much ignore everything. There shouldn't be any tags, permissions, advanced options, none of these. We're totally fine. And lastly, we scroll down and hit on create stack. Okay, and basically what happens now is CloudFormation has received the template, is now analyzing the template, calculating the change set, and calculating all the actions needed to reach that desired state. And basically, this file tells the CloudFormation what is our desired state. And our desired state in this case is to have a single S3 bucket. Okay, it shouldn't take too long. Let's refresh it. And we see that it has already completed. We have all the events stack. See that something was initiated, something was created, something has completed. It is very, very convenient now to go to the newly created resources, because there is a tab called, well, conveniently, resources. And if we click on that, we see all the resources that have been created within this stack. And since we have only declared one S3 bucket, we have one S3 entry. And again, we can click on it, open a new tab. And here we go. We have created our first resource, not through the user console, but through the CloudFormation engine. We can go back to all the files, all the buckets, and we see that it's there. So this was the easiest, the most simple example I could think of. And now let's start to advance on what we now know. For better reusability, CloudFormation templates have parameters. So for example, you have a template where you want to create a virtual machine. And for different use cases, you might want to have different amount of RAM or a different amount of CPU within those virtual machines. So it makes sense to have those parameters dynamic. So a user can decide how much performance does he need. So this is why we have this section called parameters. And again, the syntax is very, very similar. Again, we have an alias, name, ID, whatever you want to name it. And then we tell what is the type of the parameter and what is the description. So the type is string because we want to specify a bucket name. And the description is a bucket name to set. And that's it. Again, let's go back to the CloudFormation. I'm just going simply to update our current stack by just simply clicking the update part. And we're going to replace a current template, upload a new one, choose file. The second template with a newly created parameter for S3 bucket name. We open it, hit next. Now, the difference between previous step and the current one, all the parameters will ask you for some kind of value. So since we said that there is a parameter for bucket name, it must be string. So the user interface will ask you for that bucket name. Let's call it, I don't know, 1, 2, 3, whatever. Again, next, and we hit update stack. Okay, and we see that actually the user interface, or let's say the CloudFormation itself, tells us that there is no updates to be performed. So in other words, there is no difference between this template and this template. But why is that? We have created a parameter which is used to name a bucket. And the reason behind this is that we are not using this parameter anywhere. We have simply declared it, but we're not using it anywhere. We need to use that parameter on this resource if we want for this parameter to take effect. And this is where we're going to the third part, the intrinsic functions. And a CloudFormation engine has so-called intrinsic functions, which are specified with an exclamation mark. So for example, there is a join function, a reference function, and so on. And basically, what these functions allow you to do, they give you some dynamicness. Okay, they give you some dynamicness in your static templates. So for example, if you want to have a dynamic S3 bucket name, which can be specified by the user of this CloudFormation template, you would do something like this. Okay, this is, I would say, a little bit too complicated example. Let me write it even in simpler terms. So firstly, let's create a simple bucket with some kind of custom name. Okay. So this is how it's going to look like. Now we are creating an S3 bucket with this weird whatever name. Okay. So let's go back to the stacks, to the CloudWiser 101 stack. Hit update, replace current template. Again, we want to upload it. And now we're going to use this one. Now it doesn't matter what kind of parameter are we going to supply, because again, we're not using it anywhere yet. Next, and update stack. Okay, so now it detected changes. And of course it detected changes because now in the first example, we didn't specify a name. Therefore, it was automatically generated. And now we have specified the bucket name. Okay, so all the event stack is presented for us. I love that column, which stands for status reason, and it explains why some of the actions have been taken. So, for example, requested update requires the creation of a new physical resource, hence creating one. Okay, let's refresh one more time, and we see that the update was completed. And if we refresh our buckets, we see that this gibberish name of the bucket has been deployed. Now, what if we want to use that bucket, the parameter to set our bucket? We use, I say, just this part. And let me explain what it does. Okay, just making sure that it is exactly the same. Okay. So we are using an intrinsic function called ref. And ref returns a value of some kind of resource or parameter or output, whatever. In this case, we want to get a value from this parameter. And the value of this parameter is going to be whatever the user has set. So I hope this part is clear enough. And let's go back to the CloudFormation. Again, click on update, replace current template, upload, choose file, and upload the same template. Now, it should matter what we enter here. And okay, it can be test, CloudWiser, test 101. Just making sure that the name of the bucket is truly unique, because S3 bucket names have to be unique globally. And the reason for that is because S3 buckets can be used as, how do I say that? As web servers. They have their own, they can have their own DNS names and so on. So DNS names have to be globally unique. Therefore, S3 bucket names also have to be globally unique. Okay, but this was just a side note. And again, we hit update stack, and we can see again that CloudFormation saw that there are changes in our template. And again, it is being redeployed. And well, usually how we do this these presentations is we usually tend to answer questions and answers at the end. But since we have at some places some free time as we wait for the CloudFormation template to be deployed. I can answer some of your questions already, and I see there is a new question which asks, currently it creates a new bucket and deletes the old one because buckets cannot be remade. Yes, that is very correct, absolutely correct. What happens if you had some files in the bucket already and the name is changed? The answer is very simple. The deployment would fail because this is the default action that the CloudFormation was programmed to do. Because imagine you accidentally change the name of the buckets and you have fundamentally important data in your bucket. You really don't want to accidentally delete it. So it would rather fail than delete the bucket. And this is definitely the desired thing. So your data would still be protected. Okay, moving on, we see that our template has been deployed. Going back to the stacks, refresh, and indeed, we see that we have a new bucket that is test CloudVisor test one-on-one. Okay, so this is how we use this dynamicness in our templates. We use parameters, and then we reference some of the parameters in our resources. But for the intrinsic functions, it's not just about the ref. There are quite a lot more. And if we just move it, and if we go to AWS intrinsic functions, there are quite more of them. So here's the whole list. There's converting some strings into base 64, get attribute, get AC, import, join, whatever. So I'm definitely not diving in too deep into these. I'm just going to show you some of them. Okay, but the other intrinsic function I would like you to show is the join function. And I hope everyone is quite familiar with the join function in programming, where you want to join some strings. So in Python, it could be, I know, double quotes dot join, and then you give some kind of list, and it would join with some kind of delimiter, which could be, I know, dash. So with this approach, what would you get is 1-2-2-22-2. Okay, so this is basically exactly the same thing. It joins all of these values in the list with this type of delimiter. Okay, and I see that we are already 40 minutes into the presentation, so I am not going to redeploy this stack because, well, we can all guess what the output of such template would be. So if the name of the bucket is A, so it would be A-dummy-suffix. Okay.
And Lymanus, if I could just jump in quickly, we have another question from the audience, and they ask for declarative. What are tools and examples? If you could answer that as well, please.
Yeah, so for declarative approach, these are probably two most popular ones, is the CloudFormation and Terraform. So Terraform is the one that it was created with the mind of multi-cloud that could work with AWS, with Azure, with Google Cloud Platform. But as it turned out, eventually, it didn't do these things because those cloud providers were quite different. So now you have this, let's say, Terraform for AWS, Terraform for Azure, Terraform for GCP. And this declarative approach for AWS is what we see now. It is CloudFormation. So yeah, I hope I answered your question. Okay, moving on. So I think everyone is. Everything is clear with this approach, and we can move to the fourth step, and it is called mappings. So CloudFormation templates again can have even more dynamicness with so-called mappings. And we say that if some kind of value is dev, then we have this string. If the value is test, we have this string. And if the value is prod, we have this string. Be careful, it is production, okay? And the way we use these mappings is with another intrinsic function, which is called exclamation mark, find in map. And you need to provide 3 values in the correct order. So you need to provide the map itself. So this is the map. Then you need to provide a key. And in this approach, our key is a reference to our new parameter. And our new parameter, okay, I will get back to it. Let's finish with the find in map function. Okay, so with the value of the new parameter, and again the entry of such mapping, because eventually you can have more of these mappings. Okay, so you need to tell that function which of these entries should be used. So since we have only the suffix part, we tell, okay, use the suffix part. Going back to that parameter part, okay, everyone is quite familiar with the first parameter, which is the name of the bucket. But we have something more interesting. We have another parameter, which is called environment. And it has specified some allowed values. So now you will no longer be able to enter some dynamic string. You will be able to choose only one of these, the dev, the test, and the prod. And it makes sense because, as you can see, this dev, test, and prod coincides with dev, test, and prod. And we want those mappings to work nicely with each other. So the expectation would be, once we select or type the name of the bucket, we select the environment, the suffix of that bucket should be this, or this one. Okay, so let's see if that is the case. Again, going back to the CloudFormation interface, replace current templates, choose file. And now we are using the fourth one, the mapping. Again, next. And now you can see we have 2 parameters instead of one. We have the name of the bucket. Since we are updating it, it sees that it is the same. Just for fun, I will rename it once more. We have more digits now. And from the environment, you see it is a drop-down now. Let's use the production. We hit next, and update the stack. Yeah, so I see another question as I wait for it to be for the stack to complete. The question is there an example in the declarative, this CloudFormation approach, for the environment variables? The answer is yes, and you would do this through already shown parameters. And the way what you would do is you wouldn't use the user interface, right? Because obviously the user interface cannot access your system, your operating system environment variables, right? So the way you would do is you would do via a CLI command, and I have an example here. This is a CLI command, which is AWS CloudFormation deploy. You show the path to the template file, you tell the stack name, you give some capabilities, which I'm not going to talk about much. And then you specify parameters. And we can go, exactly the first one. And here you see for upload S3 prefix, KMS parameter overrides. Yeah, I think that this is the one. A parameter of structures that specify input parameters for your stack template. Yeah. So with your CLI command, you would use something like this, right? And since this is your shell file, which is being run in your environment or some virtual machine environment, now your shell script can access environment variables, and you can, well, pretty easily specify them there. They would be converted into CloudFormation parameters, CloudFormation template parameters, and they would be passed to the CloudFormation itself. Okay. I believe this has ended. And again, if we refresh it, now we see that we have the dynamic bucket name that we have specified previously with a suffix to be careful because it is a production. Okay. So I hope these mappings make sense for you. It is a pretty naive example, pretty basic one. But again, once you have started programming, right, all those hello world examples were also pretty basic, and you thought, why do I need this? But after some years, I hope you understood that there are some more advanced things going on. So the very same thing is with those mappings and with the parameters. Even though I'm showing you the basic stuff, but you should understand that there are some really advanced use cases for such constructs. Moving on, outputs. Some of the resources get some of the properties automatically generated. For example, API gateway. When you create an API gateway, there is no way to determine its endpoint, okay, because it's being dynamically generated. And you can know the endpoint of such API only when it was fully deployed. So to access some things programmatically and, for example, from the CloudFormation standpoint, sometimes it is useful to use outputs. And in this example, again, I'm going to create some dummy bucket with some dummy name. And I'm going to export an output of this bucket's Amazon resource name, or ARN for short. So let's see how it looks like. Again, we go back to the user interface, replace current template, upload template file. We select outputs, hit next, 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 and update the stack. Okay. Again, this is a pretty easy change set. We're not doing anything fancy. There are no longer mappings. There are no parameters, nothing. It's just an output. And the output, again, uses the intrinsic function, which is called getATT. And I am getting the attribute of ARN. Now, how do I know what kind of attributes does this resource have? Well, the answer is very simple. The answer is always documentation. So let's go to CloudFormation S3 bucket, to the documentation part, and see what it tells us. Well, here we see all of the possible parameters that we can supply before we create the bucket. So see type, the bucket, properties. There is bucket name, which I have provided here, right? Yeah, bucket name here. And if you go scroll down, okay, not that much down, there is the return values. And for example, if we call the intrinsic function ref on such resource, we will get the ID. If we call the get attribute intrinsic function on that resource, we can specify either it's RN, domain name, dual stack domain name, regional domain name, website URL. Okay, so for this example, I have chosen just to simply print out the Amazon resource name. Let's hope it succeeded. Yep, it succeeded. The bucket is there. And the most importantly, the output in the outputs tab is also there. So the key is bucket ARN, and this is the actual value or the ARN of the S3 bucket. So again, a pretty basic example, but as you can guess, there are more important use cases than this. And lastly, let's create something more fun. If we go back to our slides, I have showed you this picture. Let's say it's a picture, or rather an overview of an architecture. So let's try to create a fully working Lambda function. And in order to create a Lambda function, we firstly need to create a role. So this green bucket hat, whatever it's named, helmet, I think it's helmet. The role has to be created first, then the function, and the role has to be attached to the function in order for the Lambda function to fully work. Okay, so how does this look in a real world example in the CloudFormation part? So we have two resources. We have a role and we have a function. Now, the syntax is again very, very similar. We tell what is the type of our resource. So this one is role and this one is function. Our role has some properties. So if you know how identity access management works in CloudFormation, so you have roles, and roles have policies, and policies have some actions. Okay, so what we do now is we tell that we're not specifying exact policies or exact actions. We are doing something more fancy. We are copying an already AWS managed role or policy by this code statement. Again, as you can see, we are using the intrinsic join function. And again, this is the more advanced use case of such thing, because now we are dynamically generating an Amazon resource name, or ARN for short. It starts with ARN, then we have the AWS partition, and then we have the name of the role. And this role is very simple. It lets you publish some logs into CloudWatch. Okay. And lastly, we have the function. The type of it is lambda function. Now it is very interesting how we specify the code of such lambda function. There are a few ways how we can do that. We can reference the code that exists in S3 bucket, or we can do something inline. So I chose to go with the simpler approach, to do the inline approach, and this is how it looks like. You simply specify that this is a zip file, and you give it a string. So what CloudFormation will do, it will create a zip file out of the string and upload it to Lambda functions. And for those who know or don't know, this is how you basically update Lambda functions. You update them with zip files. And this is how we reference an already created custom role. Again, this is another intrinsic function. And the way we do is we get the RN of that role. And this is how you specify a role for a Lambda function. Then you specify other different parameters. And the last piece of parameter is the depends on entry. And this is very interesting one, a new one. So basically, once you create a bunch of resources that depend on each other, there is, well, there almost always there is a very direct order the way those resources have to be deployed because of all those dependencies. So in this example, and as I showed you in this picture, firstly, we need to create a role before we create a function. So this piece of code, it tells exactly that this function resource depends on role resource. And this is the way how you can tell that to CloudFormation engine. Okay, so
now just before we move on, let's just answer a couple of questions that we have from the audience.
Of course. Yeah, so I see that there are two questions. The first one is, are these changes pushed into the repo? I guess repo is for the repository. And well, it depends on what you think the repository is. If you say it is some kind of Git repository or whatever, well, natively, it is not being pushed, of course, because you do those changes, you upload it to CloudFormation, and it saves those CloudFormation templates somewhere internally, because it needs to know what is the current state in order to calculate the desired state, okay? So yeah, of course, it handles those templates somewhere internally, but yeah, these are just simply internal ones. Now, I would like to add more about this question. Since we are using files for managing our infrastructure, they can be versioned, of course. And the best way to version files is to use Git repositories, of course. So this is what usually teams do. They have one central Git repository to store their CloudFormation files, and they do various changes, pull requests to update those files. And what they usually have, they have pipelines, and on the commit or on merge action, those pipelines get triggered. Those pipelines take all those files and send those files to the CloudFormation. So you have this full nice CI/CD pipeline, which is basically versioned infrastructure. So again, I hope I answered your question. And the second one is, can you provide files to the resources? For example, content to host in the S3 bucket, code zip to execute in the Lambda? Well, the only code and the only example for today's workshop is this one that I have given you the URL to clone. Now, if you need more examples on how to use S3 bucket as a website host or a zip file to update a lambda function, well, basically there are quite a lot of tutorials out there by AWS or by other developers. And I would say this is a little bit out of today's scope, because I want to mainly focus on today's topic, which is the CloudFormation itself. Okay, so yeah, so all these other things can definitely be found on the internet, and I won't be talking about them. Okay, so let's continue. Let's try to update it. To deploy it. Again, I will just try to change some of the names, because I think I have already deployed it, so I don't want there to be any clashes between my different infrastructures. Yeah, I think this is also there. Okay. And yep, let's try the exact same thing as we did for the couple of times already. We replace current template, upload a template, choose file, use this one. Next, there are no parameters. Next, and this is a very interesting part. Previously, once we were deploying those CloudFormation templates, these capabilities notice wasn't there. And it always appears when you create new roles in your CloudFormation template. So it basically asks you, are you absolutely sure you want to create IAM resources? And I say, yes, I'm absolutely sure. And we hit update. And well, the path is fairly similar. It is going to, firstly, it is going to delete our S3 bucket because it is no longer there. Hence, the change set is to delete the bucket. And since we don't have this role and this function, it will create them. So 1 delete action, 2 create actions. Okay, it was again pretty quick. Now, if we go to the resources part, yes, indeed, we see that there were created 2 resources. One is the role and another is the function. We can, of course, open the lambda function, index.py, and we see that this is pretty much exactly the same code as we had it there. Let's try to test it. And you see that the execution was successful. So I believe that's it. That is it for the CloudFormation part. We created a very, very, very simple infrastructure. We created a single lambda function to do some useless stuff. And yeah, as I previously mentioned, this declarative approach is very, very powerful. However, I really don't like working with those CloudFormation templates, especially when you need to manage 10 or 100,000 of resources, because now you need to use nested stacks, multiple files, and so on. The dependencies between stacks becomes very, very complicated, and there has to be an easier way. And thankfully, I'm not the only one that thinks that this is not how developers should interact with the infrastructure. People think that developers should interact with infrastructure by using a real programming code. And that is why we have things like DOMs, or document object models. And what DOMs allows us to do is they allow us to write an actual programming code in our favorite languages. So for example, since my favorite language is Python, there is a wonderful open source tool, which is called Troposphere. And this is probably the best example of a DOM approach. So now, instead of creating these CloudFormation templates, you use some nice Python code, and you get all the benefits of if statements, for and while loops, and all the other good magic that programming provides you. I remember there was a question in the Q&A session which asked, how about those environment variables? Well, here is the answer. Since now you're using the Python obviously can access the operating system environment variable. So you can simply os.environment.get and you get the environment variable, which is extremely convenient. And now you don't even need to use parameters, because now the whole CloudFormation template is going to be created dynamically. So I've been using Troposphere for quite a lot of time, but it didn't feel right either. And the main reason is that the code that I wrote, it was pretty declarative, as declarative as the CloudFormation template itself. And at one point I understood that these DOMs are, well, frankly, simple wrappers, very simple wrappers for your existing CloudFormation template structures, nothing else. And as you can see, yes, we are doing this in very declarative way. We create a function, even though it's Pythonic code, but it's very static. We create a resource, again, very declarative approach. And I really missed the dynamicness of this code. Again, I really missed abstractions, and I think programming is all about abstractions. So I have started searching for even better tools, and thankfully I found them. And the next step of such so-called DOMs is the components approach. And one of the best examples of this components approach is AWS CDK. And what it allows us to write is it allows us to write a beautiful programming code as it should be. It's no longer declarative. Now it has all these inheritance things, some functions that modify objects and so on. So this is a very good example. Let's say we create two resources in a declarative way, which is auto scaling group and an application load balancer. But this is where the beautiful part begins, because now we have these methods that modify modify already created instances. So for example, for the load balancer, we add a listener on port 80. For that listener, we add a new target, again for the port 80. The target is the auto-scaling group. And in that auto-scaling group, we have a machine image, which is basically a standard Amazon Linux 2 operating system instance. And finally, we open a default port to the world by simply invoking this command, listener.connections.allow default port from any IPv4. And this immediately felt as a right way to program, right? And the right way to manage your infrastructure. And it's not only about these methods, of course. There are many more real code examples, such as polymorphism and inheritance, where you can start inheriting from some basic structures in AWS CDK. It's called a construct, and the constructs get inherited by some, I don't know, say basic roles, and then this role can be inherited by some specific role, the very specific implementation of a role, and so on. And because of that, you get the best practice structures. And one of the very, very good examples I like to tell everyone is creating that ECS cluster with load balancers, auto-scaling groups, and all of these resources. If you would do this in, let's say, a simple CloudFormation template in the declarative way, I don't know. I mean, it would take you a couple of weeks maybe if you would have to do this from scratch without copying anything. Okay, it would be very, very painful. However, with such a components approach, which has some built-in structures within, there is, I believe, something like 30 lines of code, which basically creates all the ECS cluster infrastructure for you, all the load balancers, target groups, security groups, VPCs, you name it, whatever. Everything that is just there. So, and it does it in a so-called best practices way. So once I have started using this AWS CDK tool, I immediately fell in love with it, as I understood that, yep, it does some really cool magic that I love. It lets me create these very, very advanced structures, very, very advanced architectures in such an easy way. So yeah, I think now that it might be one of the best approach how you can handle your AWS infrastructure. So again, let's continue with our second session. Our second workshop, and now creating the same exact resource, just the lambda function with the role, is going to be just too easy for us. So what I figured out, let's do something more advanced. Let's create an S3 bucket, a lambda function, and let's create a trigger that every time we put anything into S3 bucket, it would immediately invoke a lambda function. Okay, so this, now we have some more advanced interactions between our resources. So let's do that. Going back to my IDE, now we can close our first session and open the second one. And all these files that you see here are a part of a standard AWS CDK structure. Now, we can open a terminal. And for those who don't have installed a CDK tool, it is very easy. You can simply write npm install globally, and I think it's AWS-CDK. And since I have already installed a CDK, I think it will fail. Yep, it failed because with some strange whatever error, but it only fails with this type of error whenever you have already installed it. So if I just simply write CDK, it should work with no problem. So the install command is npm i-g for global and AWS CDK. And actually, the exact same thing is written in the README documentation that you can also take a glance at. So once we have installed the CDK, we can try create a dummy project. And for dummy project, we need a dummy directory. Let's call it dummy. Let's go to the dummy, and the command to create a new CDK project is CDK init, very similar to git init, and we need to specify a language, because if I'm not going to specify a language, it will ask us, what language do you want to write in? So is it C#, is it F#, is it Java, JavaScript, Python, or TypeScript? Well, as my favorite language of choice is Python, I'm going to use Python, of course. And once you complete this, we can go to the desktop part and see that there is the dummy, and it's visually, or let's say structurally, it is very, very similar. We have .app.py, cdk.json, some README files, requirements, setup. This file is just for Windows users. Yeah, so this is the structure that we see, and it is the default structure that was created with that simple command that I have shown you previously. Now, since it is a normal CDK project or normal Python library, we have things like requirements.txt and setup.py, which give you some more metadata on your libraries. The most important, for example, metadata probably is the install requires part, where you specify all of the dependencies. And for interacting with AWS CDK tool, we have lots of different dependencies. So since we are going to, where's our PowerPoint, to create an S3 bucket, a lambda function, and a role, well, we simply specify that we have a dependency to an S3 bucket, a dependency to a lambda function, and so on. Just to know what all of the dependencies are, I think this is the PyPy, and you can simply write AWS CDK, and yep, these are basically 201 projects. Basically, all of the libraries that were created by AWS CDK team, and probably every single AWS service that exists here in the console, and there's quite a lot of them, has its own Python CDK package, which is basically here, right? Okay. So going back to our example, since this is a Python code, it makes sense to create a virtual environment, so not to mess up with our global environment. So let's go to the second session, and let's create a virtual environment, which is usually done like this. Again, if you don't want to, you can skip this part. It is not mandatory to create a virtual environment. However, it is just a good practice to do so. Okay. Let's wait a couple of seconds. And now, since we have created that virtual environment, we need to activate it. So to activate it, we simply write source and path to the activation script, which in our case is vnv/bin/activate. And we know it was activated since there is a prefix of the name of the virtual environment. Okay. And lastly, before we start working with our CDK project, is we need to install all of the dependencies. And to install them, simply write pip install -r for the recursive operation, and anything that is specified in the requirements.txt file. And if we open the requirements.txt file, we see some weird gibberish over here. And the minus E is a flag for to install this package as an editable package. And the dash basically tells for the pip tool to look at the setup.py file. And once it looks at the setup.py file, it sees all the install requires dependencies and installs them. So as you can see, it installed quite a lot of them, from auto-scaling to events to SQS and so on. And it is basically because all of these dependencies have even more dependencies underneath. All right. Since we have created everything, let's open the default workshop directory and let's open the workshop stack. Right? And this is basically the code that you will find. And this is it. This is something like 20 lines of code to create our so desired infrastructure, which again, if you need to do it in CloudFormation, it would be hundreds and hundreds and hundreds lines of code. But let's start simple. Let's comment out anything that is related to functions and S3 notifications. And let's be very simple. Let's just create, again, a very, very simple S3 bucket as we did here. Just 3 lines of code. Okay, so it is fairly very similar. You have a little bit more lines of code because of these 2 things that are AWS CDK specific. So for the name of the bucket, I think I have, again, already deployed something like that. So I will just rename it. And now to, to execute the deployment, we simply write CDK deploy -- all. And it will deploy all of the stacks that are available here. So again, let's execute it. Yeah, please change the name of the bucket, because if everyone is going to deploy the same name, the deployment is going to fail, because it will tell that the S3 bucket already exists. So yeah, please change the name. Okay, and again, the CDK has a very nice interface. It prints all of the events here exactly to your console. So again, you can see all the changes that take place in real time. But of course, at the same time, we can just simply refresh and then see that, okay, it completed. But this template also appears, of course, it appears in the CloudFormation user interface. And I think what I missed to explain it to you, that the way AWS CDK works is very similar to the DOM approach. It gets your Pythonic code, in this example, Python, right? It gets your Pythonic code, and it converts your Pythonic code into CloudFormation templates. And then it sends those CloudFormation templates to the CloudFormation engine. And we already know how those CloudFormation templates look like, what they can do, and so on, and how the way AWS, this CloudFormation engine works. So the main idea of this DOM and the main idea of for example, AWS CDK is to not interact with these ugly CloudFormation templates. This is basically the main idea, okay? And since you don't have to interact with those templates, it becomes very, very easy to manage your code. So this is the idea of such tools. And this is why we go back to the CloudFormation, because at the end of the day, it is still CloudFormation, but we no longer need to deal with those templates. And if we open those templates, we see that it was quite complex for something simple as the bucket. And basically it is because it adds some automatically generated metadata. So for example, it adds metadata for modules that have been used to create this stack. Okay. Once we have created the bucket, now let's create a function. Again, I know I'm just going to rename it just in order it not to clash. But now creating the function is, again, very, very simple. And it is quite more simple than this 30 lines of code, because here we not only had to specify the function, but we also had to specify a role. And the way CDK works is if you don't specify a role, it will create one, the default one, immediately for you. And lastly we have a notification, that beautiful function that modifies our objects, and it allows us the interaction, this gray arrow interaction between the S3 bucket and the lambda function. And again, this is specified very, very beautifully with this line of code, which again is just an elegant line of code. And that's it. Again, we write CDK deploy -- all. And now, since we are creating some roles, it will ask us again, are you absolutely sure you want to create these roles? Yes, of course, we're absolutely sure. That's why we specify yes. And that's it. All the change set will be calculated, and the infrastructure will be deployed accordingly. So since now it is being deployed, let's answer some questions.
Oh, that's very good. I was gonna say
that
we have some questions piling up for you.
Yeah, okay. So the first one is, please share the link for the Tropo tool. So it's called Troposphere, and well, it's simply Troposphere GitHub. Very simple, Troposphere, and that's it. There are some good examples and so on. So yeah, of course, I can give you in the chat to all panelists. Okay, and yeah, I've been using this tool for quite a lot of time. I really enjoyed it, but would I recommend it? No, I wouldn't recommend it, because there is a better tool, which is called AWS CDK, which handles the infrastructure in much more elegant way. Okay. The second question is, can you put 2 languages? The answer is yes and no. So if you want to have one project, then obviously that project has to be written in the same language, either it's C#, Python, whatever. But what we do, at least in our team, we have multiple different projects that maintain only some piece of the whole infrastructure. And those projects don't know about each other anything. So the answer is yes. one project can be written in C#, the other one can be written in Java, and the third one can be written in Python. And you can execute all of them in the exactly same way. They will produce their own templates, or if we want to compare them, they would produce exactly the same templates. And the CloudFormation engine would understand those templates in exactly the same manner. However, there is another answer to this question if we are talking about something like Lambda functions. And yes, you can write a Python infrastructure code and supply source code for your Lambda functions within your project. And that source code can be completely different language. It can be Python, it can be C#, again, it can be Go, it can be assembly. No, it cannot be assembly language. What am I saying? AWS Lambdas don't support assembly, but yes. So there are different kinds of approaches to use multiple languages. Either these are separate projects, or you are supplying some programming code for your Lambda functions. Okay, so I think we can skip some of the questions for later use and just see whether it succeeded. Yes, it did. If we go to the resources, we see we have quite a lot of resources going on. And most importantly, we have the function, we have the bucket, and we have quite some other resources like custom resources. And custom resources in CloudFormation is a very, very powerful structure allowing you to do, well, you guessed it, custom actions. And those custom actions are usually backed by a Lambda function. That is why you see multiple Lambda functions. There is one and there is another, even though we have created only one, right? But this let's say interaction between the Lambda function and this S3 bucket was fulfilled via this so-called custom resource. And this custom resource was backed by a custom Lambda function, which contains some custom programming code. This is why we have a little bit more resources than usual. But again, this is the beauty, the elegance of this AWS CDK tool, as it hides everything from us. So we don't need to worry about these interactions that are probably not supported by the CloudFormation itself, but they are supported by CDK via custom resources. Okay, so for the lack of time, as we are approaching the end of the deadline, let's say, of our presentation, I am not going to show you how these resources work, and I will very quickly jump back to my presentation, and I will try to quickly summarize everything that we saw today. So as I was giving you the presentation from the perspective of how we manage our infrastructure, and I talked quite a lot of CloudFormation, about the CDK and so on, I think you might already have realized some of the benefits of such tools, but let me give you a full picture. What is the benefit of an infrastructure as code principle? So I have thought of 6 examples. So the first one is mirror-like infrastructures. So this reproducibility, so-called. So it is very, very, very easy to have 10 different AWS environments with exactly mirror-like infrastructures. One can be used for testing, one for development, one for staging, one for auditing, one for production, one for pre-production, whatever. All of them can have exactly the same infrastructure. And because of this, well, and not only of this, this approach is very friendly for auditing. And if you write some serious software, and I hope some of us do that, they are very prone to audits because management usually wants to validate them, or the customers want to validate them, and ensure that the software that you write is audited and compliant. So having this infrastructure as code implementation into your software development is very, very audit friendly, because now when an external party vendor auditor comes to you, you only have to look at that programming code, and you see the whole picture of all those interactions, of all those configurations and possible misconfigurations and so on. So auditors are usually very, very happy when they see an infrastructure that is written in the infrastructure as code principle. The third one is the very easy state management. And this is true for the components, for the DOMs, and for the declarative way, because at the end of the day, you don't need to think about how are you going to transition from your old state to a new state. It is the headache for CloudFormation, not you. You just define the desired state, and it's up to CloudFormation to figure out how to get there. The fourth reason, the fourth benefit is that it is very, very easy to duplicate complex structures. I give you an example with those ECS clusters, 30 lines of code. And if you want to have one ECS cluster for one business logic and another ECS cluster for another business logic, it is a matter of copying and pasting your code, 30 or even less lines of code. And especially if you're using AWS, something like AWS CDK, we get all those polymorphisms, inheritance, and other things. So we don't even need to copy and paste. We can have some base classes, some abstract classes, and so on, to even further go like next level beyond. The fifth one is, of course, since we're talking about infrastructure as code, you get all the benefits of the code principles. So you get the versioning, pull requests, pipelines, and all this good stuff. I think versioning and pull requests is probably the most important ones, because now your infrastructure or some parts of your infrastructure can have versions. And if you need to roll back, you just roll back a version and you redeploy. Very, very easy to manage your states. And the last one, and one of the most important, at least for me, is the big picture view. In one central place, I can see everything. I can see all the interactions between resources, all the roles and other things. And I can even specify for some base functions or some base classes, the default security group, and all of the other resources will inherit from that very secure, let's say, security group. And it is very, very easy to manage from the big picture perspective. Also, the question is when you should use infrastructure as code, such as CloudFormation or AWS CDK. Well, to be honest, it doesn't make sense to use infrastructure as code if you have some monolithic architecture. If you have a single EC2 instance that hosts user interface, business logic, data logic, and all other things under one virtual machine. Because what are you going to do with this CloudFormation template? You're not doing anything. So you can just do it manually. However, it makes sense to have this infrastructure as code approach when your architecture tends to move towards microservices. And again, not the amount of microservices that you see in the middle, like 1, 2, 3, 4, 5, 6, 7, because it is, again, quite easy to manage them. But when your architecture tends to move to something like below in this black picture, I think it is the representation of Netflix's architecture. And you see that big chaos, big mess, lots of traffic, lots of microservices and so on. So in these type of scenarios, it absolutely makes sense to use infrastructure as code, because if you're not going to use it, you're just going to lose yourself in all this mess. So for the summary part, I think there is at least one sentence that you should take away from this presentation, and it's a very simple one. Infrastructure as code principle in a modern microservices architecture is a must. I don't think it is a nice to have thing. I don't think it's optional. I personally believe that it is a must. So that's it for my presentation. Consider it done, and let's go to the questions part, and let's answer the remaining ones. So I see that there is a question. What happens if you write your infrastructure in one version of CDK, and after the update, they change some method calls, packages, etc.? I see that CDK is very rapidly developed. Yes, that is very correct. It is insanely rapidly developed. Does this mean you need to constantly update your infrastructure code? Well, from my perspective, and as I've been using the CDK tool for something like 3 years, the answer is no, because even though that development is very rapid, those updates usually aren't breaking. Okay, they are just updates to an existing functionality, and very less of breaking updates are being released throughout all those releases. The second thing is you don't need to use always the latest version of those packages, right? So for example, let's go back to this one example and the set of the pie. You see that I have put the equals sign. And this basically tells that use this version of CDK and nothing else. And with this type of approach, you don't need to worry about all the later updates, which might potentially be breaking, and to always deploy to your production and pre-production versions, the environments, the very specific versions. And yeah, it works really well. And this is actually how you should do that. You should deploy to your environments with very specific versions. So yeah, that would be my answer to this question. The second question is it the same kind of declarative in Azure and GCP? What do you think? Yes, the answer is absolutely yes. Very similar approaches are in other AWS competitors, such as Azure or GCP. They all have their own implementation of infrastructure as code principle. However, to be honest, I have never used them, but to be honest, all of the cloud providers are more or less similar with their functionality. So I would guess the infrastructure as code implementation is, again, fairly similar. However, I think that there is only AWS currently that offers this AWS CDK package, this type of abstraction, this level of abstraction. I think currently only the AWS has it. Yeah, so I think I have answered all of the questions. Not sure if any other remain.
Well, thank you very much, Limonas. A virtual round of applause are going to you for this insightful workshop. If anyone still has any questions, then pop them in the chat box. Limonas is still here to answer, and you can do it just right now. And in addition, I would like to encourage everyone to join our Amazon Web Services Community Baltics channel on Slack. I'm posting the link in the chat box just right now. So make sure you sign up. You will find a lot of useful information and like-minded people in there.
Yeah, and to add a little bit more, so if you join something like this Baltics Community Slack channel, I'm there, other developers are also there, so you can ask your questions actually in that Slack channel also. So it's all good.
Yeah, so if you're gonna come up with a question later on, make sure you chase down Limonas on the Slack channel. I'm sure he will help you.
Yeah, I think someone said that the link is not active.
I'll just double check it real quick.
Yeah, the link is no longer active.
Well, I might have been given a wrong link, but we will definitely send an invite link as a follow-up email with a recorded presentation tomorrow. So I can see there are no more questions coming up. So thank you once again very much. Thank you. I hope it was very useful for everyone who attended. And one last thing to mention, guys, on your way out, once you exit the Zoom call, there's going to be a little survey. So please spend a minute to fill it in. It would really help us to grow and make sure that those workshops are even more useful and even more targeted to you guys.
Okay. Thank you everyone for joining. Thank you.
Thank you, everyone. Nice to be here, and see you soon in our CloudVisor events. Until the next time.
Bye.
Bye-bye.